Greetings, friends. Welcome back to another week of probability and stochastics. Today we are looking at homework 10, question 2. So from the lecture notes, we are asked to collect the definitions of properties of these stochastic processes. We have the wide sense stationary process, independent increment process, the Markov process, normal process, strict sense stationary process, the white noise, and the mean ergodic process. And basically, just like number one, they asked us to explain our understanding about these properties. So A, wide sense stationary WSS process. This refers to a process where the mean is a constant and autocorrelation is a function of time difference. And WSS is used for state estimation, parameter estimation, and prediction in a mean square sense. And a linear time invariant system, if we input something that's wide sense stationary, we should expect an output that is also wide sense stationary. B, independent increment process. So basically, we've seen this up on the Poisson process right here. So increments is basically telling us that random variables within n t1 t2 and n t3 t4, they're independent if they don't overlap. And we saw from one at the Poisson process, random walk, and a Wiener process were independent increment processes. So C, Markov process. Basically, that's saying if we're given the present, the future is independent of the past. And examples of these, in our understanding, basically everything actually, except for a few Poisson process, Poisson impulses, semi-random telegraph, random walk, and Wiener processes. So let me see. I don't think there was. Yeah, I don't think there was increments there. Yeah, I think it's basically everything from 1 except for Poisson increments. Anyways, normal process. Process where random variables xt1, xt2, all the way to xtn are jointly normal for any t1, t2, all the way to tn. Statistics determined in terms of mean and autocorrelation. E, strict sense stationary process. So statistics within this process isn't affected by a shift in time. So we kind of talked about that just a bit in number one. So basically, in our understanding of this, we have to prove this pretty difficult thing whenever we're trying to prove an SSS process. F of x, x1, x2, all the way to xn, within t1, t2, all the way to tn. This has to basically equal to each other when we are shifting, t1, t2, all the way to tn by epsilon to be wide sense stationary. White noise. This process defines such when when the mean is 0. Basically, expected value of v of t equals 0, and has an impulse autocorrelation function, rv of t1, t2 equals q times q of t1, and we have what was that? There's like a delta. Yeah, delta of t1 minus t2. Lastly, mean ergodic. The stochastic process x of t is defined as such if limit of t approaches infinity. All this 1 over 2t integral of x of t dt equals the expected value of x of t in the mean square sense. That is pretty much it for this question. Thank you for watching.